Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our webinar, Plug and Play Live AI Workflows in Action, brought to you by our friends Teradata and Coder. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI ecosystem for enterprise leaders. Today, we're excited to welcome hundreds of attendees from around the world to explore how AI tools truly perform in real-world workflows, not just demos, but in action. Plug and Play sessions are all about showing, not telling. In this hands-on webinar series, you'll see tech leaders walk through their AI product in real time, highlighting exactly how it works in the wild, workflows, and integrations. Built on the momentum of our AI Demo Day and Agentic AI Showcase formats, Plug and Play goes deeper. Today, our presenters will slow down and dig in, demonstrating usability, showing off speed to value, and guiding you through common real-world scenarios. We're honored to hear from two distinguished experts. Janeth Graziani, developer advocate at Teradata, and Michael Suchacz, engineering manager at Coder. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right side. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address, or the speakers to address, excuse me. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right cycle. And finally, to learn more about how to move beyond prototypes and gain a deeper understanding of how AI solutions operate in real-world workflows from integration to measurable value, check out the calls to action below throughout the webinar from our sponsors. Now, without further ado, I'm excited to kick off our webinar with our first presenter, who is Janeth Graziani from Teradata. Welcome, Janeth.
Hello, thank you so much for having me. Very, very excited to be here. I am Janeth Graziani, developer advocate at Teradata, and I have prepared a lab for us all. I will also start with a quick slide deck. I promise not to bore you all with the slide deck. I will zoom through it. So if you don't mind, I will go ahead and share my screen. Let's share this. Great. Perfect. Amazing. Okay, so today, as mentioned, I have prepared a lab where we will walk through the build of an agentic system that can reason across your unstructured and structured data, your documents, your tables, using Teradata on Google Cloud. And as mentioned, I work for Teradata. If you're not familiar with Teradata, Teradata serves some of the largest enterprises. We serve 10 of the top 10 banks, including JPMorgan Chase, Citibank, Bank of America, and others. Some of the top airlines, including Lufthansa, American, Delta, United, and some telco companies, including Vodafone, Verizon, and others that you've probably interacted with before. Now, Teradata serves them with AI, advanced analytics, AI, machine learning, and agentic AI systems that handle critical workloads. And this is a graphical representation of our autonomous AI and knowledge platform. Our developers access, through AI Studio, they can access Agent Stack, which enables them to build agents fairly quickly. And they can connect these agents to our enterprise context, our autonomous knowledge platform, using enterprise MCP. And at the very bottom of this graphical representation, we have our knowledge, our autonomous knowledge platform that can be deployed across any of your preferred cloud service providers, whether that's Google Cloud, AWS, or Azure. Of course, Google Cloud for our audience today. And our customers can also choose to deploy, to have our services on-prem using Factory, or hybrid deployments using Fabric. So that's a quick introduction of who Teradata is. And now I'd love to jump into today's main presentation. So we will drop a link in the chat where you can access today's lab. Please hold off any questions till the very end, and I will do my best to answer those questions. I might have some of my colleagues joining this session, so they may also be able to chime in. but I will do my best. So let's start with defining an agent, right? As the word agentic gets thrown around deliberately. And the way I like to define an agent is a system that when provided with a goal and a set of tools and an LLM, that system will use the LLM to reason towards achieving that goal by using the tools that are provided. Now, given this definition, we understand that not every chatbot is an agent, right? For example, if you think of your free version of ChatGPT in the browser, that's a simple generative AI system. However, it can be connected and hooked onto your two additional tools so that it can perform tasks on your behalf. And that's when it becomes an agentic system. It has an LLM, large language model, and tools available in its tool set. Also, the LLM is not an agent. An LLM is a simple generative AI system, right? So just some quick definitions there. And now if we zoom into the components of what makes up an agent, it's made up of four main components, right? We have the inputs, the runtime, the LLM, and the tools. Now, the runtime is what makes our agent run, right? It's where the system will receive the inputs. It will perform multiple calls to the LLM so that it can, until the LLM identifies and figures out that it has achieved the goal and has enough context and information to provide us with an answer, right? And in the runtime, the agent manages its state. It holds a history of the messages between the system and the user. And the inputs that go into our runtime, there are two types of inputs. There is our system prompt and our user prompt. The system prompt is built by or created by the developer, the engineer developing the agent. And we can think of the system prompt as setting the boundaries for what our agent can do. And the user prompt is the tasks that our end user requests of our agent within those boundaries, right? So we will see how the LLM will, we will invoke the LLM will use the messages passed into it as well as awareness of the available tools, and it will try to reason to achieve the goal. And really quick here, this is a great representation of this runtime. So when we're developing our agents, this is what we will see as we build our runtime, right? Here we have a really simple Python code that shows us how this runtime can be structured, right? We passed in our system prompt, our user messages, and our tools. Now, notice here that our system prompt and our user message are passed in through this messages object. It's a role-based object where we define our system and user message. Now, when the LLM, when we enter the reasoning stage in our agent runtime, the LLM will take in our messages, our tools, it will reason over those, and if it decides it needs to perform a tool execution, it will execute that tool call, and then it will append the results into the messages object. So the role will be tools here, and the content will be the tool output, right? So this is just a quick recap of how our runtime within our agent works, taking all of the components together: the runtime, the LLM, the tool execution, and the system prompts. So building this runtime, this loop can become complex fairly quickly, right? And thankfully, we have many leading frameworks that abstract a lot of the work that developers have to put into standing up one of these runtimes, so building everything from scratch. And Teradata integrates seamlessly with a lot of these frameworks like LangChain, LangGraph, LangFlow, and we also have integrations with low-code, no-code tools that enable us to build our agent systems. And today in the lab coming up, I will show you how we can build an agentic system using Agent Builder, Teradata's Agent Builder, with a LangChain integration, and Teradata Enterprise MCP to establish a connection to our enterprise knowledge. data sitting in a table and in an enterprise vector store. Now, there are 3 stages of agentic development. So when we think of developing our agentic systems, we start with the build stage, then we move on to deploy and manage and monitor. Under the build stage is what we covered. That's when we develop our runtime. We create our system prompt, and we create tools so that our agent can access our data in a secure, governed fashion. And that's what we're going to see today. Now, after you're done building your agent, you have to think about how you're going to package that agent, how you're going to package those components. You have to think about the infrastructure that you need to be able to serve your end users. You have to think about how many users are going to access your system, where they're located, and other challenges that might come up when you think about deployment and infrastructure, how to make your system scalable. And Teradata offers Agent Engine to make this process seamless, all in one platform. We also have to think about, once your agent is deployed into production, you need to monitor your agentic AI systems, your agentic AI workflows, so that you understand the success rate of your agent, if there are any issues with your agent, the tools that are being called, and other information that may be critical to your organization. And Teradata also offers this observability through Agent Ops. But for today, I will demonstrate the build portion of this demonstration. We don't have too much time, but in future sessions, I would love to come back and take us through the entire life cycle of building and deploying an agent. So what are we building today? We're going to build our first agent using Agent Builder Pro Code with a LangChain framework, Teradata MCP to establish that connection with our agent system to our enterprise knowledge base. And we are also going to see how easy it is to spin up a vector store in Teradata, embed our documentation, and perform fast similarity search against that documentation. So what kind of agent are we building? This is a quick recap of what we're building today. So let's suppose we are a finance team at a large company, at a large enterprise, and we need to understand or identify customers that are eligible to receive a loyalty discount. So in theory, that sounds very simple, right? However, if we start thinking about what this involves, it's a bit more challenging. If you have hundreds, thousands of customers, that's one challenge. The other challenge is that the policies that determine eligibility for our customers to receive loyalty discounts, those policies live in unstructured documents, your Wikidocs, your PDFs, your composite files. Now, those policies can change depending on any updates to the documents, right, to the clauses. So your agent needs to be able to retrieve the latest policy, reason over it, and then it needs to be able to retrieve business attributes, business facts, your information on your customers, and those live in a separate location. Those live in structured tables. Your agent will have to take that knowledge, reason over it, and give us an explainable, audit-ready answer. So this is very different than your typical text-to-SQL agent. The agent doesn't generate SQL. It will operate through approved MCP tools that we will create in the session, and it will reason over both the unstructured and the structured data. And it will cite what policy it used and the facts it used. So this is the architecture of what we will be building today. Our agent is composed of 3 core layers. We can think about our agent having 3 core layers. To the left-hand side, we have our enterprise context. This is our knowledge, where a lot of our information is stored. We have our enterprise vector store that will contain our policy clauses, and our Vantage Cloud on Google that contains our structured business information in a structured format. We are going to provide access to our enterprise context via MCP tools. We're going to give our agent access to the knowledge via approved predefined MCP tools. And for the reasoning layer, we're going to use LangChain to create a runtime and an LLM to reason over the policy documents and the business facts and to output a response. So I would like to invite you all to follow along in the lab. You can head on over to teradata.com/experience. You can scan the QR code and follow along as I run through the demo, or you can tab it for later, come back to it and play around with it. So I will switch over to a different screen. And actually, I think I can just toggle. There we go. Perfect. Okay, great. Can everyone see my screen? I can see you in the chat. If you give me a quick message, I will continue. Okay, awesome. I see thumbs up. Great. Thank you so much. Okay, so once you head on over to teradata.com/experience, here you can create a free account and follow the workflow to create your account and log in. Now, once you log in, you are taken to this dashboard. And if it's your first time entering the experience, you won't have any environments. This will be very bare with, you might see a plus button, something similar to this create a new environment button. So you can create your first environment, select it, give your environment a name, give it a database password, and select the region closest to you to avoid latency. So once your environment is up and running, you can stop it, start it, and delete it here. So using these connection details for your Teradata system, you will be able to connect your Teradata system to other applications, to other third-party tools. You can begin ingesting data, transforming that data, building your models, building your agentic AI systems with whatever sample data you want to load. For today's demonstration, I have prepared a sample notebook. So once you select the Run Demos button, that will open up this hosted Jupyter Lab on a separate tab, which gives you access to over 200 notebooks, a great learning resource across AI, ML, advanced analytics, and agentic AI. So I would highly encourage you to log in and explore these. For today's demonstration, I will navigate through Vantage Cloud Lake, the directory, and find the use cases directory. Select the governed LangChain Teradata agent, and you will find today's notebook, LangChain Teradata MCP agent. So I've already given a quick introduction of the agent that we are building today. Our agent will be able to read unstructured and structured data, reason over it, and provide us with a very, very focused answer, right? Let's actually clear all outputs. Great, and let's refresh just to make sure we get a fresh start. Awesome. So let's begin by covering the build of our demo. We start by configuring our environment. We are loading our libraries. We are loading our Teradata MCP server. This is the open source implementation of Teradata's enterprise MCP that allows us to access tools to interact with our database, with our vector store. Then we install our LangChain Teradata Python library to integrate more seamlessly with LangChain frameworks and to quickly build our enterprise vector store. And LangChain MCP adapters to quickly spin up our MCP server and to be able to access our knowledge. Now, LangChain for our framework, and I'm using Panel for a quick, lightweight chatbot UI. So once we have installed these libraries, we can import the specific modules for our demonstration. So let's begin first by doing a little bit of data management before we even start building our agent. We are going to first create our vector store, and we're going to generate embeddings for our policy documents. These policy documents that define eligibility for this business to receive a loyalty discount. So to do that, we need to establish a connection to our Teradata system. Here I am connecting to my Teradata system using the create context function available in Teradata ML. I pass in my credentials Now, when you log in and you access this notebook, your environment files will hold all the credentials you need to walk through, to connect to a Teradata system and follow along with this notebook. Great, so once you have established a connection, we then need to authenticate into our user environment services. This will give you access to Teradata's generative AI capabilities, as well as to the ability to create a vector store and start generating embeddings. Awesome. So once that authentication is set and successful, we can begin loading our documents into our enterprise vector store. So here I have a simple sample documentation. Now, this can be your PDF files, your more extensive wiki docs. For simple demo purposes, I have defined a business loyalty program where a business is eligible to receive a loyalty discount if it is active, enterprise, and has at least 12 months of tenure. I have also defined hard exclusions. I have set regional exceptions and even stated that government accounts cannot never be auto-approved for discounts. They need manual approval and review. So once my documents are ready to load into my Teradata Enterprise Vector Store, I can use the LangChain Teradata library and the Teradata Vector Store class to quickly generate embeddings over those documents and perform fast similarity search over them. So here I provide my vector store with a unique name, and then I use the from documents method to quickly embed those documents. And I select the embedding model I want to work with. You can experiment with any model, any Gemini model, any Google models available for embeddings. And once your vector store is created, you can use different methods to check the status of your enterprise vector store. The VS status method will let us know when it is ready. And then we can also use the get details method to view additional details for our vector store. We can see the sample size we're working with, the embedding model we used, embedding dimensions, metrics, search algorithms, and other information that may be important to our developers. Now we can confirm that our embeddings were generated. We get this data frame when we use this get index embeddings method, and we can confirm that our embeddings are in fact generated. So this represents the unstructured portion of our demonstration. These are the business policy clauses that determine eligibility for providing a customer with a discount, right? Now let's quickly review the data that sits in a Teradata table. Here we have this demo financial business table that houses my business attributes. We have customer information such as the business name, the business type, the region, the status, risk flags, and start date. So if I wanted to identify if Acme Co. is eligible to receive a loyalty discount, I would need to review the information, right? I have Acme Co., an enterprise in North America with an active status, no risk flags, and a 10-year start date of October 1st, 2024. So I can already tell that I would have to perform calculations to identify the tenure of Acme Co. The loyalty discount policies allow us to allocate a 10% loyalty discount if the business has over 12 months of tenure. So I will automate this entire workflow by building our agentic AI system. Now, I want to reiterate that my agent system, my agent runtime, will only have access to the enterprise vector store and to the table, to the information that I want to give it access to. I will create custom SQL tools that I will expose through MCP so that only certain information is available to my agent and to the LLM that I'm using. So let's begin building our agent. To build custom MCP tools, I first we'll create this MCP config directory that will house declarative YAML files. And I will explain what happens once I run the server. So I have this MCP directory, and inside that MCP directory, I will house two different YAML files, an objects.yaml file, finance_objects.yaml. This file contains my custom SQL tool. I'm calling it Finance Check Business Loyalty Eligibility. This custom SQL tool, it's a simple select tool, SQL tool that returns the business attributes that my LLM will need to determine if this customer is eligible or not to receive a loyalty discount. And once I define this tool, once I declare this tool, I then create a profiles.yaml file to register this tool under a specific role. I'm creating a finance analyst profile, and I am giving this profile access to my custom SQL tool, as well as the Teradata vector store module, which exposes additional tools to this role so that we can interact with our Teradata vector store. So now we have all the tools our agent will need to interact with our enterprise context. So what happens is when I start the MCP here using LangChain's MCP adapters, I am pointing to the config directory and to the specific role, the specific profile we created. And this will extend the available tools in our open source Teradata MCP server. And now, as you can see here, I have access to these various tools that allow me to interact with my vector store. In today's demo, I will use the TDVS similarity search to retrieve semantically similar documents based on the query. And I will also be using my my custom SQL tool to retrieve business facts from my table. Awesome. So for the sake of time, I will skip these examples, and let's start by building our agent. So this is where we start building our agent runtime. The first thing we need to do is initialize our LLM. You can use whatever model you want to use. I have tested with Gemini. I have tested with multiple models. It all works great. So feel free to experiment and explore with different models. Once you've initialized your LLM, the next thing would be to create your agent. We have the LLM, we have the tools. So all we need to do is set up our runtime. So we're using LangChain agents, create agent to build our runtime. And we're passing in our LLM, our specific MCP tools, and we are also passing in a system prompt to tell our agent how it should, within what boundaries it should behave. And I'll return to review this system prompt in a second. So we have a quick chatbot UI with panel. So let's test our agent. Let's wake it up. Hello. The first query is a little bit longer than usual. Let's ask a question such as, we know that we reviewed Evergreen. So let's ask, is Acme Co eligible for a loyalty discount? Let's stop that first query and let's try this. So what is going to happen here? Our agent will, so our runtime is running at the moment. I'm sorry. Our agent will follow the system prompt that we have created. It will first call the TDVS similarity search tool that it has access to in its tool set against our vector store. And it will use that to retrieve the official policy clauses. Then we'll call the custom SQL tool that we created and we gave it access to. We'll pass in the required parameter, and then it will follow these rules and return a response in this cleanly formatted fashion. It will give us a decision whether Acme Co is eligible or not to receive this loyalty discount, it will give us the supporting policy clauses, and it will also show us the SQL executed and the results. So if all has worked well, we should see the answer. And here we have it. So we see the decision that it is eligible to receive a loyalty discount. It presents us with the supporting policy clauses. And here we have the SQL that we used. So yeah, this really, I would love to show more, but I fear that I am running out of time. So this just shows you how easy it was to build, to develop the agent using our integrations with LangChain, our agent runtime, our Teradata Enterprise Vector Store to generate those embeddings, make sense of that information, and allow our agent to reason over both the policy clauses and the structured business information in a Teradata table. Yeah, I'm happy to open up the floor to any questions. This is available for you all to explore. Take your time to review, play around with it, upload your own data, and see what else you can build.
Thanks, Janeth. And we are just about out of time, so I think it looks like we have a question in the chat, but you may maybe best to answer that offline since we're just about coming up on time here. But excellent presentation, really enjoyed it. And if you guys like what you saw, make sure that you click the call to action from Teradata below and book a follow-up with them. Thanks, Janeth.
Thank you so much.
And I'm excited to welcome our next presenter to the stage, Michael Suchacz from Coder, Engineering Manager. Welcome, Michael.
Hey.
And we will turn things over to you.
Okie dokie. Thanks for having me. Good evening, everyone, because it is an evening for me. Let me start by telling you a bit about Coder as a company, because it will, I think, give you a bit of a better context as to why we've kind of been experimenting with what I'm about to show you here. So historically, I think even up to this date, when people are creating software, they're usually using their own hardware, as in a laptop or a PC, where in a typical scenario, if you're doing something just for yourself, it's pretty fine. But if you are a CSIO or anybody else trying to make sure that the, end compute is safe and that we can control what software engineers use, that tends to become really hard because engineers like their tools and they want to use different things. And you kind of have this inability to control everything that happens. And there are some workarounds like virtual desktops or managing some virtual machines, but all of them kind of suffer from usability and the interaction actually looks like. So what Coder basically is and how the product has came to life is a cloud development environment. So a way for admins, platform administrators, people that are focused on security, to create and define environments that are run on a self-hosted infrastructure that developers can very easily interact with through their IDEs and through terminals, and to have a much better interaction compared to like a virtual machine or a VDI, but at the same time giving the admins the ability to control kind of the end laptops, and at the same time making sure that all developers at an organization have a similar onboarding experience, have access to the same updated tools, etc. When the AI era came to life, we've sort of realized that a lot of the same principles that we have been applying to human builders also apply to agent builders. So if you imagine an agent as sort of a compute running around free that actually wants to have access to all of these tools in order to complete the tasks you've given it, it seems like the use case is very similar. Of course, there are some limitations. You maybe don't want the agent to have access to the outside world. You want to limit what it can do with your source code. But all of that you can actually define as sort of a sandbox and put it into the same use as you would a workspace. So that naturally kind of brought Coder as a company that is very much a prepared one to kind of handle this agentic set of problems. And we've spun up a couple of teams that were tasked with solving various issues around this. I dropped a link to some of our customers and their success stories if you want to explore a bit more and to how they have been solving their problems, because I think there's a wide variety of things that you could be solving with Coder specifically. The general AI problem, of course, is the cost, the speed, and the reliability. The cost is something that a lot of us will need to worry about sooner or later. Once the hype drops, it will sort of be the same as it was with cloud computing and kind of understanding how to make those agents efficient at what they do. So what I'm talking about is I think that some of the stuff that is important for humans now, which is security, compliance, infrastructure, provisioning, standards, all of that are the things that are sort of table stakes when you're trying to deploy those agents at an enterprise scale, and sort of the thing that we've already solved, and we are now applying to a different scale and to a different subset of problems. When I'm saying efficiency, usually you would think to yourself, okay, efficiency is lower cost, right? Just less of everything. But to be honest, you should frame efficiency more of a best quality you can get for the unit that you're investing into it. So an agent that you will put $2 in might give you the result that you're actually looking for, whereas if you try to use a cheaper model, it will give you the result faster and for less money, but at the same time, you will have to have a human in the loop, improving the results quite a bit. Because I think Janeth already covered some of this, so I'll briefly skip through it. But what you would usually call the agent runtime is an agent harness. An agent harness you can understand as tools like Cloud Code or Codex, or some of the stuff like Mux that we have built in Coder, which is basically the control around how we call the LLM provider, what tools do we give them, what kind of context are we assembling, what are we telling the agent it can do, and how we control its behavior. So the agentic loop is basically about getting the task, assembling the context, calling the model, getting the response back, executing some tool calls, and then running this in the loop until the agent sort of communicates that it thinks it's done. One of the things that we've tried as sort of a nice way to figure out how to make those models a bit more cost efficient is something called programmatic tool calling. It's an approach in which you're telling the agent that instead of calling a tool one by one, which it likes to do, so it likes to tell your computer or kind of your harness to read a file, this file, read that file, read another file. What you can try doing is tell the agent to actually write a script. Write a script in which you will read a couple of files and then you will draw conclusions out of that. An example is sort of, instead of us having to query something 5 times, we can tell the agent to run the query for 5 parameters and then do an operation, and all of that will happen inside of a single tool call. So instead of going back and forth with the LLM provider, we can just do it once and the code will execute on our machine. It's a cool concept, which some of the providers are actually doing, but instead of having this execution on your compute, they will have it on their own cloud, for which you will, of course, pay a bit, but the concept is out there. Some of the context management strategies that you can look at is how you window the context, how much of the history is relevant, how much do you summarize, how often do you do compaction. Basically, what context is, if you haven't really dove deep into the LLM world, it's sort of like a brain of the model. So the model itself, once it's trained and once it's out there, theoretically doesn't gain any new knowledge. The knowledge that you're giving to the model and the task you're giving to the model are locked within a context. The context is a specific amount of tokens. Tokens do not directly translate to bytes, but you can sort of think of it like an amount of data that you can give, or like the amount of data that the model can keep at the same time while evaluating the outcome of your tools or evaluating your next prompts. So sort of like the brain of the model. And there have been some evaluations out there that usually around 50 to 60% of the context, if it's occupied, the model already is starting to diverge a bit. It doesn't always remember everything you've told it to do and stuff like that. So we were sort of trying to experiment with different techniques that one can use in order to get better results by managing the context of this. One of the very popular trends in a lot of the agent harnesses has become to distribute the cognitive load, which very much, I would say, reflects how humans would usually think about their tasks and how they would pass it around. So you would give a specific task to one person, a different type of task to a different person, and by that you will be preserving their kind of cognitive load by making sure that they can all work in parallel, and then they can come back to you with results of their work, which is something that we've also been trying to figure out. There are some trade-offs to that because you do have the overhead of orchestrating those agents, of passing the data. You cannot reuse the cache that you've sent before to the LLM because you're spinning sort of a new agent. So you kind of lose that, but there are some benefits in terms of the quality for sure, and that you can, for easier tasks, use smaller models. Like in the case of Anthropic, you could use a Haiku, which is a small, fast, cheap model that also has been trained to not hallucinate as much because it doesn't necessarily need to come up with a solution, but more execute on a simple task. So you can kind of weigh in those models into your workflow and make sure that they execute faster, cheaper, and with less hallucinations. There's also another cool concept that we've been sort of exploring, and that was to compare whether we can program around those agents as we would approach a human brain. There is quite a nice book that talks about it, where it defines sort of two thinking systems in our head. One is called System 1, another one is called System 2. System 1 is the fast one, our instincts, the way we can immediately react to seeing something or hearing something. And it's our intuition that basically comes with not a lot of cost and gives pretty good results. What we were kind of trying to do when applying this was that because we have so many tool calls happening, and all of those tool calls usually have big outputs, right? If you're running a set of tests, if you're trying to display a file, you'll usually get a lot of context. And in order to prevent the model from actually loading all of it into the context, we were trying to apply those cheap small models like Haikus to just go over that output and to only pass the relevant sections back to the main agent. Kind of all of those that we were trying to do, some of them gave us value, some of them didn't. And I sort of wanted to talk a bit about what we were using in order to verify this. So the tool that we've built initially for ourselves, but it is available as open source, and you can go check it out and play around with it. It's something we call the coding agent multiplexer, but in essence, it's a way for you to manage a lot of those agents around multiple projects, repositories, playing around with different types of LLM providers, local models, Anthropic, OpenAI, Google, whatever you can think. There's a config for that. It's a very extensible tool with the idea to give something to power users where they can fully configure their own workflows and kind of define a set of different runtimes where those will be executed, et cetera, et cetera. What we were using to verify those was called Terminal Bench. It is an open source framework for evaluating LLMs that consists of 80, I think 4 or 6 tasks of various complexity around things like security and coding and stuff like that. So when for this particular presentation, I didn't execute the entire suite. I've taken 9 random tasks that were kind of completed by most of the models, or at least they achieved a result instead of timing out. And the pass rate that we've seen was that Cloud Code, which is the harness that Anthropic has for Opus, had a 78% rate, which was kind of our reference base. It had a pretty low cost for all of this, and it completed all of those tasks within give or take 4 minutes. Which the funny thing is that a lot of the experiments, what we were trying to achieve by them, didn't really pan out exactly as we were thinking. So the System 1 experiment, while it was cheaper and it was much faster, it also gave us worse results. So hiding some of the output actually made it so the model was not able to reason as well about the stuff that it was supposed to do, and then it was losing context, and then it wasn't passing the tasks as much. But we were able to achieve it in a bit of a cheaper approach. For us specifically, the harness that we've created around the OpenAI GPT 5.4 was giving very good results at a bit of a higher cost than Opus. But for example, it got better results than OpenAI's own Codex harness, which means that there were some tricks that we were able to pull off in terms of controlling the agent and its behavior. There are some cool examples in this. So one of them was this task called sanitize Git repo, where there was given a Git history, and the agent was supposed to clean kind of data that was tokens or secrets and stuff like that. And for example, only the Cloudflare Opus was able to complete it with a very cheap cost, whereas all of the other models sort of failed. And specific reasons was that Mux, in almost all of the scenarios, never touched one of the files. Whereas GPT was much more overeager and was touching extra files that it shouldn't have been touching. So you can see that while you can think of a lot of tricks around those LLMs and how to optimize them and how to play around with them, nobody can really give you like a super well described approach that will solve all of your problems. Although this is about experimentation, it's also about accepting that they are non-deterministic in nature and that you will basically be sacrificing some things for other things. In the spirit of time, and to kind of show you how the tool works, this is the UI of Mux, which is a desktop application that works on all platforms. It is also hostable as a web service, so as an app on a web server. So the interface is that I have a project called Coder, which is our main repository. I can define which type of workspace I would like to have. I usually work on work trees, which most of you who have worked with Claude probably know. It's a way for Git to create like a local copy of your repo with just a single branch, so the agent can work undisrupted in its own isolated folder. So I'm using that, using main as my source branch, and I'm telling the model to create a plan for adding bulk cancel option on the workspaces page. I'm also linking an issue, but basically what I'm asking the model to do is that if you go to the Coder dashboard and you add a couple of things, currently you get this bulk actions that only tell you to start, stop, update, or delete your workspaces. Sometimes when the build is running, I want to have the ability to cancel it. And in order to do that by bulk, I have to ask my LLM to help me code it. An approach that you will often hear about when thinking about how to be efficient and how to get good results with the LLMs is to use the plan mode. Most providers have this. This is an idea that the model will be told to do a lot of exploration, to understand your code base, to understand the problem, but in no way it should actually start to write code. The only thing the model should be doing is to start exploring, getting information, and the end result that I want from the model is to create a plan. Usually, of course, it takes a bit to collect all of the information, start the work tree, but we can start to see the reasoning of the model, whereas it will usually tell you that the plan mode instructs me to reserve files reading for specific cases, blah, 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 and all of that, which comes with a system prompt explaining to the agent what it needs to do. Then we can see at the bottom that the agent has created a to-do list where it is investigating issues, requirements, and whatnot. In order to give you a bit more on how the end result will look, I've sent the same prompt before we had our demo, so I can look at what it comes up with. And it comes up with a plan. Usually it will tell me, okay, I verified the context where the relevant actions are. My implementation plan is to mirror the existing row level cancel rules for bulk selection, etc., etc. What I usually do in my flow is that I review the kind of goal to make sure that we're thinking about the same thing. I review the implementation plan because that will, in a very simple way, tell me exactly what I would sort of do on my own as a software engineer. And then I can just, and then I can just start the orchestration. I got a question for zooming in. I'll try. I'm not sure it actually works that way. Zooming in. It does work a bit better. Let me then, because this is the one that you see here is an Electron app, and this, I don't think it will zoom that nicely, or will it? Oh, it will. Nice. This is a feature that I have not yet explored in this tool, and it's awesome that it works without me testing it before. I hope this is a bit better and easier to read. So right now, when I asked the model to start the orchestration, it will look at what it is supposed to be doing and then break it down into tasks. And then you can see that the plan that we've asked to create before is actually spinning up sub-agents. So it's spun up a smaller agent using the Haiku model. And the task is to investigate backend API, shared client plumbing, blah, blah, blah. And then basically, the LLM will go through all of those files and try to come up with a simple version of this context and feed it into the main agent. Why is it important? It is important because if we look at the context that I'm using right now, even though the Opus model usually has quite a big context window, right now I'm only using 26,000 of that. Even though you can see that when you look at the actual components, I've been sending many more tokens, but none of them are getting into the context window of this main agent that I, as the human, interact with, because all of this work and all of this complexity is being put in those sub-agents. They do the grunt work, and they only come back with the relevant pieces of information. Why I call Mux a tool for power users that want to experiment and play a bit more is that because all of this kind of behavior and how this works, you can configure in settings. So it's a lot of toggles. It's a lot of toggles to understand and to play around with and to know consequences of. However, if you're kind of deep into that and you want to optimize your workflows, you definitely have the ability with this tool to kind of dive deeper. To define, for example, the exec agent is the one that actually writes source code. I really like the GPT 5.4 model on it. I'm not setting it to the highest reasoning because it usually tends to run a bit too long, but it gets good results on this. For the orchestration model, I use Opus because Anthropic, actually, because they have it in their own tool. They've trained the model to break down tasks really well, and the model understands that. And going forward, it actually, from what we've been seeing, it does a pretty good job of understanding which tasks can be parallelized and then breaks it down into smaller pieces. The plan model, I like how OpenAI kind of created their model to be a bit more centric around the architecture and not kind of skewing around. So that's why I use. And for the sub-agent and exploration, I really like Haiku because Anthropic trained this model to not hallucinate and to be very resistant to figuring out its own things. It will try to read the files or the information that you've asked it of and come back with results. No additional context that it thinks it's relevant, only focusing on the actual result. I've mentioned before that we do have a lot of providers. You can configure local models. You can use Bedrock. You can use your GitHub Copilot subscription. We have our own Mux Gateway. You can use OpenRouter. We do track our issues on GitHub. So if there's something that's missing here and you think it would be nice to add, you can always reach out to us. We are very eager to kind of expand on the capabilities of that tool. And yeah. We do have access to MCPs. I think some people were asking around that. It's kind of a way for you to spin up capabilities around external tools and give them to your agents. So, for example, I am here right now having the MCP for DevTools, which is giving the agent the ability to interact with my browser. Okay. Speaking of all of that, while Mux is a great tool and we really love it, it very quickly became clear to us that it is not a tool for everyone. Not everyone will like the complexity, not everyone will be able to utilize the complexity. And because we have so many different options, it's very easy for users who maybe are unaware of some of the complexities behind to basically make the tool inefficient for them. Which is why we've recently been starting working and kind of we started working. It's available in early access, and it's something we call Coder Agents. which is a similar mindset of giving people the ability to operate an agent in kind of an isolated environment where the admins can control the runtime and make sure that the access to tools is locked down. But also the interface is much simpler. It's much more familiar. It is what users like and have kind of grown accustomed to along the way. So I'm adding in the same prompt to this tool. Of course, Anthropic API is just let me see if that's the case or if the tool is giving us, okay, it should be working, I guess. Maybe it's just a false positive. Let me see. Magic of live demo. You gotta love it. I'll spin up another one using GPT just in case, so I have something to show. I took the kind of the same approach before, where I was able to put in the same prompt to just see how this works. The chat is longer, yeah. So I've asked the model to fix and dock with this issue. You can see the interface is a bit clearer. It tries to speak more of a human language instead of giving you all of those bash tool calls and tells you exactly what it's doing, whether it's reading files, listing them. It is using the GitHub MCP, so it doesn't have to do like a lot of things in the workspace. It can do them on the fly and give you quick responses. When the agent was kind of exploring, finding certain things, for all of the things that you see here, the agent actually was using sub-agents, but they're just not that exposed in the UI. And we figured that it shouldn't really be that important for the end user whether a sub-agent did something or not. They have the ability to go back to it and like check specifically what the sub-agent did, but they don't necessarily have to. They can just kind of rely on the output that they're seeing in the main window. So we've gotten a plan where the changes would be. You can see that the plan, of course, is a bit different from Max, and it's because I have a completely different system prompt for how I like my plans here. This shows you an experience that is sort of tailored to your users. The way this works underneath the hood is that we actually are running this on our own internal infrastructure. So the agent is not doing anything in the cloud. The only thing that goes to the internet is the calls that we are making to Anthropic or OpenAI or Bedrock. The rest of the things happens internally on our infrastructure. So it's a much easier feedback loop for the agent to kind of work on workspaces. It is reusing the same templates that we've defined for our engineers, so it actually knows the coder repository quite well. We've given it all the tools. We've given it a lot of context. So the plans that it comes up with are much more complete and kind of ready to implement. One very cool thing that we have done when figuring this out is to add the capability to control a computer for the agent. I think I have some screenshots. Yeah, I think the zoom is killing me a bit here. Let me see if I can zoom out. Yeah, here it is. But is this one? This one was better, I think. Okay, so we've created an open source library called Portable Desktop. It is available in our GitHub as well. How the library works is that in a Linux runtime, it actually starts a small X server and gives the agent the ability to open up apps on it, interact with them, click around, kind of use the computer exactly like a human would. So when I told the agent to dogfood the solution and for the agent to actually verify what it has built, you can see that the agent opened up the Chrome browser, started the Storybook service, put in the path, and was able to actually verify that the cancel button that I wanted actually appeared in the menu, which makes the feedback loop much faster for us. We've been seeing that it's so much easier if we have a PR that we think is ready to put it in the agent and tell the agent to run all the scenarios, make all the screenshots, make sure that the UI looks consistent, that the actions work like you would expect them to work, and stuff like that, which is pretty cool. We've seen it give great results in terms of like just verifying, making some screenshots for README or for docs. So yeah, all of that is available through early access. If you want to check it out, you can. Actually, github.com/coder. You can go into the repository. There is a README, the setup instructions, how to run it locally. It is a pretty flawless experience to try it out and see whether it would be a nice fit for you, either in a home lab, on your company, or for your team. And we also have the Mux repo, which is also open source, available. You can read on how to download it, how to start working with it, links to docs. We have a Discord where we welcome all users. And yeah, I think that's it for me.
Excellent. Thanks, Michael. Great presentation and learning more about Coder. If you guys liked what you saw, make sure you book a follow-up with Coder at that call to action below. And with that, we conclude our quarterly plug-and-play session. I want to thank you all for joining us. If you missed any of this webinar or want to rewatch anything, make sure that you refresh this page after the conclusion of the webinar, and you'll be able to access the recording, and we'll also send out a link to the recording tomorrow. I want to say a special thank you to Michael and Janeth for joining us and excellent presentations. And of course, very much appreciate the support of Teradata and Coder for excellent webinar possible. So we'll see all of you again next time.